This is going to be a workshop on climate and health using the En-ROADS simulator. We're going to be thinking about various futures using an interactive tool that you can use yourself. You can engage other people with it. It is free and online. And of course, our hosts are the American Public Health Association and the Medical Society Consortium on Climate and Health. I'm Andrew Jones of Climate Interactive. We're the team that built the simulator along with MIT Sloan. We'll be giving you that simulator in a minute. Right now, we're welcoming people and asking you to write where you are coming from and what your name is. We got Aviva from Jersey, folks from DC and other places. But it's 5 minutes past, so let's get going. And I want to pass it to my colleague, Lisa Patel. Please, Lisa, you would welcome everybody.
Yeah, so thanks so much for joining us, and we're excited to partner with APHA on this. The Medical Society Consortium, we bring together 58 medical societies representing over 1 million physicians in the country, in addition to being in 30 states where we have state clinician groups representing physicians, pharmacists, nurses, public health professionals, a really interdisciplinary collaboration. I think we're really excited to promote this tool amongst our network, recognizing that there's really an important opportunity to help build more public consciousness and activation around what these solutions can mean in terms of benefit in a really visual and data-driven way. So we're really excited for this work, and I'll hand it back to Drew.
All right, I think we actually get some words from Shweta next, don't we?
Yes, just real quick.
Great.
Good afternoon, everyone, and I would like to welcome you all. My name is Shweta Arya. I use she, her pronouns, and I'm a senior project manager with the Center for Climate Health and Equity at the American Public Health Association. This workshop couldn't be more timely. Just yesterday, APHA released a statement posing the EPA's proposal to roll back clean air protections, because the public health consequences of such actions are real and far-reaching. And that's exactly why tools like the En-ROADS simulations are so powerful. They help us visualize how emissions and the policies that shape them impact both our environment and our health. So without any further ado, I hand it back to Drew. Enjoy the presentation and the simulation.
All right. I trust you can see my screen. We are Climate Interactive, a not-for-profit climate tech company here in the US, 14 people working to create simulations for the world, along with our colleagues at MIT in the Sloan School of Management and the Climate Pathways Project. We're funded primarily by philanthropy. In your world, you may notice that W at the bottom. Wellcome Trust funded us to add the health measures that you're about to see here. The primary use case is taking the simulator, putting it on a wall, and asking groups of 10 to 20 to 500 people, like members of US Congress, to talk about what we're going to do to prevent the climate and health catastrophe that is here and growing. Talking to each other, grounded in the best available science. That's why the simulator is on the wall. So when someone says, hey, I think that eating vegan is going to have a big effect on reducing temperature in the future in Omaha, Nebraska, is the kind of thing that comes up in Congress, we can simulate how much that is true. And it's kind of true, as you'll see in a minute. And not just with the liberals. This is with now Senator John Curtis, who is a Republican in the US and uses the simulator himself. It's also free and available online. Ava, could you go ahead and just post the link? You can open up the simulator. It is being used in 21 languages around the world. Why is it being used? It's being used because it is incredibly easy to use and accessible. We're going to show you more in a minute, and you're going to have a chance to play with it, but you can see that you click here, for example, if we had more insulation in buildings and industry and energy efficiency, and watch what happens. The simulator runs really quickly, energy changes, emissions change, and you can see an impact on temperature. And more importantly, you can see the impact on things that matter, like how much PM 2.5 emissions, which is implicated in so many health problems related to air quality. We'll be able to test those. So that's the core of what we do with the simulator. And you're going to be getting in small groups and trying it yourself in just a minute. But before that, let's ground ourselves in, hold on a second, in in a poll question. And my question is, all right, climate and health. We're going to be curious about where you've experienced this by having you open another browser window or your phone if you have to, but ideally a browser window. And Ava, could you post into chat? Go to chat and you should see this link. PolEv, Climate 935, that link up there at the top, or the QR code. And you can go into this poll and answer the question. What is a climate and health event or trend that you have experienced yourself or someone you care about or maybe learned about? But no, this is really about what you've experienced and ideally where did you experience extreme heat? So the LA wildfires, air quality problems, just deaths from fires, people died, flooding in Virginia Beach, and all the health impacts from flooding, extreme heat, absolutely smoke, uh, extreme heat, flooding in Virginia Beach. Thank you. This is it. Please answer the poll question. Northern Virginia, the emissions problems, respiratory problems, people can't go outside, mental health problems because they're stuck in their homes in Northern Virginia. The Pacific Northwest heat dome in 2021 affected you. Wildfire smoke, Seattle and New York City. British Columbia broke records of heat in the last few years. Heat is a dangerous thing, particularly for the most vulnerable in in our communities. Hurricane Katrina in New Orleans. I'm in Asheville, North Carolina. Hurricane Helene just hit us. I know about that, oh Katrina person. Extreme heat, wildfires, and water scarcity. Extreme heat in Delhi. Yes. Lyme disease, it's really shifting where the ticks that carry Lyme disease can thrive, how long of a season they have in northern Michigan, and the air quality alerts. Premature births, we almost added that to our model, but just didn't have the courage because it was so heartbreaking to see the numbers of premature births in a warmer world. Hurricane Sandy in New England in the US. Okay, it is here, it is now, it is happening. This is not just about our grandkids. Okay, given that, what would you like to explore the most? These are the areas where we can explore heat and air pollution, wildfires, and what's coming, how much can be avoided, nutrition, vector ecology. Vector ecology, boy, the ticks for the Lyme disease would be there. Flooding. Yeah, where are the votes? Extreme heat, food supply, and nutrition. Heat and food supply and nutrition. Thank you. Heat, food supply, air pollution is now climbing. Okay, this is what you'd like to see. So a bonus question on heat. When you think of it in the future, and maybe take another, this is not a quick answer one. When you think about it, which aspect of it is the most telling? How often it happens? Where? Giving wet bulb, or wet bulb is heat and humidity. Where for extreme heat in maps? Or this is more of an economic kind of issue in labor, outdoor labor days. Straight up death globally. Do you think globally about this or no? I'm more curious about regional variability, and it's frequency I'm seeing, and I'm seeing the regional variability. Frequency and regional variability are getting the most votes. Okay, Well, let's go and dig in. Here we are. All right. I gave you the really short intro, but I want to ground you a little bit. So the biggest votes were
We'll meet
heat,
downstairs.
heat, food supply and nutrition, and air pollution. And that's where we're going to go. But we want to explore this in the context of a possible future for the climate. And that's a function of how much we do to prevent it. So that's what we're going to be able to do is change futures and then see what does it do to these different indicators that we care about in the context of a baseline future. This is not our prediction of where we think things are headed. I think things are going to be much better than this. But this is a reasonable, if the world doesn't take much more significant action, a reasonable estimate of what's going to happen. What's going to happen for energy is that we're going to burn, and note, this is a global model. So many of you are in the United States. Do not think of the United States because 11% of emissions are in the United States right now. This is mostly a story of where the emissions are growing into the future. China, India, Indonesia, Brazil, South Africa, Argentina, Mexico, South Africa. This is where emissions are growing. Coal there in the brown. On top of it is the oil that's expected to be produced. Mind you, we're the biggest producer here in the US. We're the biggest producer of natural gas as well in blue, but we're going to burn a good bit of natural gas. See that green wedge? That's the clean energy revolution, wind and solar expanding more and more as we go from here in 2025 out to 2100. Some bioenergy, burning trees for energy, and then a little bit of nuclear at the top. This could change. Another huge factor that matters so much is the other big greenhouse gas, methane. And you probably hear a lot about cows. That's here in yellow, but below it is leakage mostly from energy production. And on top is landfills and wastewater, what's called waste emissions. So those are the big sources. You put all that together and you get this graph right here, which is the bad stuff. This is the pollution. Climate science is kind of simple. There's this stuff, greenhouse gases, goes into the atmosphere, traps heat, creates the health impacts that we're tracking. See that little blip? That's the COVID blip. There's a tiny little wiggle right there in 2008. The economy changed a little bit. Okay, so we're going to explore what it would be like if we do very little. And you asked about a bunch of things, but you really focused on heat. And you said, when you said heat, you said frequency and then variability of impacts in different countries. So here are all the impacts. So I'm partly showing this because in a minute, you're going to open up this simulator in small groups and try it yourself. Here in impacts, you can scroll through this whole area and see all the things that you can look at. You're going to be looking at extreme weather. This is where heat, we're going to go there in a minute. Health and economy, like air pollution and crop nutrients. We'll go there in a minute. Oceans, these are the environmental ones, which have some health impacts. And then wildfire and drought and other impacts like that. But you said heat, and you said heat and humidity, I believe. Someone in chat, if you would, where? You said we want to see heat and humidity, and maybe I don't actually see the chat at the moment. So if someone could call out to me. Oh no, I actually see it now. So where shall we look at heat impacts around the world? Please write into chat. Oh, and Samantha said it really sad if we're still using that much coal at 2100. Yes, it is. It would be sad. Let's not do that. And we're going to see how much better it is if we don't. British Columbia, Adele, you got the first. You came up first. You're a fast typist. So I'm going to look at that area. And for that, it's not about heat and humidity. It's really about extreme heat days. So this is a measure of not humidity as well because it's so dry in British Columbia. in the future. It always is dry. Okay, so what you see here, and our friends at Probable Futures gave us access to these amazing maps. So there's North America, and you can go in and type any place or go and look. I think this is British Columbia. Um, if we look at a city, we can look at places like out here, uh, this area. And what we see is the color indicates how many days a year is above 90. And the way to think of this is starting in 2000, how many days uh, were there back then? This is the world as it was when and even previous to this, when we built most of the infrastructure. So if you look at this area, Gold River, Campbell River, this area was built to expect maybe a week of 90-degree weather. Now we can explore when the temperature globally was zero point 0.8 degrees C. Now, what we can then explore, so let's look at like Gold River here. And if you go through the years, here's where it's going to be soon, still 1 to 7. And then by 2070, and then out here, we can see by the end of the century, these areas have shifted from 1 to 7 to 8 to 30, up to a month. And so some of the resilience that is built into areas to be able to deal with extreme heat for a short period of time will be challenged and pushed when you get to 2 weeks or 3 weeks of this kind of heat. So this is a chance to see, where are we headed? What would we really like to avoid, which would be this kind of level of heat? The second one, and mind you, and when you get this, go look at other places that really matter to you, and you can do that same test for another part of the world. Say here, where you can see what was the world back here in 2000, where are things headed? So there's just one little sample, and I'm only able to give you a sampler because the goal of this is to teach you how to get around and use this tool yourself to look at what you're curious about. When I asked about heat, you said variability of deaths from extreme heat. So here's the global trend, deaths per 100,000 people. And then over on the left, we can see how this breaks down around the world. We have this rise from here around 8 deaths per 100,000 in 2080, over doubling. And the experience is quite different in different parts of the world based on the heat, but also the capacity of these regions to deal with the heat. It's both of those factors. Southeast Asia is much higher, deaths up 52. Southern Europe, where we had that terrible heat wave. I remember 2005 when thousands of people died. That really was one of the things that got me into this movement. 49. But we can explore different parts of the world and see, what does this look like? Note, in a baseline future that, frankly, we're going to in a minute see how much of this can we prevent. The next one that you voted for was food supply and nutrition. And here we can look at crop yields and under impacts as well. The other food one is crop nutrients. These are very different. Crop yield is driven by temperature, and we're concerned about the possibility of a 19% drop in maize yield. That's like production per acre or hectare. Today it's at 5. You see the gray line, headed to 19. And just to note, I don't want to be glib taking you through this. Like I want to respect how challenging it can be to see some of these numbers that we're already at a 5% drop in crop yield. Note, in a world where, click on the 3 dots here, global population is here at 8 billion and headed towards about 10. We need to be ready to feed 10 billion people around the world with crop yield falling. This is the global challenge we see. And the second challenge is about nutrition. This is not driven by temperature, but the studies have shown us that when there's a higher concentration of carbon in the atmosphere, plants grow faster, but they grow with less protein and other important nutrients. Now, as I say this, you say, protein, well, what else? Where did that come from? Click on this triangle in the corner, and it'll explain to you what I just said is lower levels of zinc, iron, and protein. Those are the other nutrients. Scroll down though, and frankly, because we love scientific papers, we think of this as a trick to get you to go read some awesome scientific papers, like in Nature 2014, Increasing CO2 Threatens Human Nutrition. So these are the sources, these are the papers that are available. And by the way, when you see relationships like this and you're like, whoa, what? Where is a lot of this based on? All of the equations are shared. Every equation is published here for you to go look at. In fact, you could go look at the health area and see where did we get the results for this? What are the studies we used? And then what are all of the equations and constants? Baseline global health year mortality is 3.6 people a year. Every equation is shared. And one other important thing is that we compare our results against the behavior of other models as well in this area of integrated assessment models. Here's the page where we compare against other models for coal, for example. Okay, enough nerding out. We were talking about nutrition, and we expect, because of the increased concentration of carbon in the atmosphere, that crop nutrients will be lower, 4.7% for maize and 11 for wheat and rice and soybeans. Okay. Oh, you actually asked for a third, and the third one was air pollution. I skimmed over it earlier. It's headed here. This is Beijing. This is New Delhi. This is many parts of the world, particularly driven by coal. And some good news coming, folks. There are things that make this do so much better in a minute. And that's what we're going to try to do, is come up with policies that can bend some of these curves. However, that's where we're headed. That should motivate us in two ways. One of them is, let's prepare the health world for what's coming. Secondly, let's do all we can to prevent climate change so that we reduce the drivers of these health challenges. And that's the next place to go, is what can be done to prevent these challenges. And I'm going to ask you another poll to create some better futures. And this will sample what you're going to be doing yourself in just a minute. I'm skipping through. I think I had one. What would you like to test? So please go to the poll. In the world of how can we prevent this challenge? And I think I gave you like 4 votes. So vote away. You get a lot of votes here. What shall we do? Encourage renewable energy, remove subsidies from fossil fuels, phase out fossil fuels, reduce deforestation. We're getting votes for food systems, energy and efficiency in transport, carbon pricing. Now, note, when we do workshops, say with the Congress and in schools, and we have had kids do this, we spend a lot of time going through this slowly. In a minute, I'm going to go through these pretty quickly because we really want to see more about the health impacts. And that's where we're going to be going. But keep voting. Keep voting. You're doing great. Keep voting. What's getting the votes? Renewable energy, food systems, phase out fossil fuels. Food, renewables, phase out fossil fuels. Yeah. Okay. And subsidies from fossil fuels. Great. No one likes nuclear. We're going to electrify some. Fantastic. And enjoy this for a second. You're creating a vision of a world addressing climate change. That's partly why we're doing this, to We spend a lot of time and energy on how bad it could be, like we just did a minute ago. Let's spend a little energy on envisioning what we'd like to see the world do. Okay, I've seen a lot of votes. Food, renewables, uh, fossil fuels. And okay, you'll be doing this in a second yourself. But the first thing you said was food. Food. I'm going to pull up methane and I think I'll pull up nitrous oxide. Am I going to do that? Yeah, why not? Nitrous oxide is a often forgotten gas, but it's very important, and it's particularly in fertilizer. And when we think about food systems, think of it in two ways. Think about how much production there is, how much food do we have to make of different types, crops, animal-based, and then secondly, when we do produce it, what is the greenhouse gas intensity? Are we doing practices that can make us kind of more efficient, but more efficient gas-wise? So under here, you see other uh, sources, agricultural emissions, and this is the most basic level. If you go into the MIT museum, this is sitting here, and you get a eighth grade kid can walk up and just click the buttons. There are no numbers at the bottom. You might be numbers people, and so you're going to click on these three dots, and you want to see exactly what's going on underneath the hood. So you'll scroll down here, and you'll see food from animals and food waste. I'm going to move this to a really high level percent of food from that. Right now, we're about 30% by weight of our diet by 2100 is from animals. And I'm going to reduce it a good bit. So this is wide scale adoption of people just eating less meat. And we do it, I want you to think, what might it do to temperature? What's it going to do to methane? What's it going to do? I'm a little fuzzy. What's it going to do to nitrous oxide, which is in fertilizer? So I'm going to hit this and we see a change. Click it again. We see a change. The yellow area in methane is shrinking. Less emissions in the food area and less fertilizer needed. Why less fertilizer? We're growing less crops to feed to animals, and don't think of hamburgers. It's not about meat as much as it is dairy, frankly. That's where the cattle impact is the most. Less farting and burping from cows, less methane emissions. If we have less food waste, that'll cut it even more. But then there's the area of how we manage methane and our animals. And are we adopting best practices of nitrous oxide and methane? And that can squeeze it a little more. And then also in crops, and that can squeeze it a little more. Now, zero point 0.2 degrees. Now, what did you see? Did it save the world? No. Did it help? Well, absolutely. We're not headed towards 3.3 degrees. We're headed at 3.1 and did some other really good things. What happened to emissions from land use? It's a little bit less. We're not chopping down trees to make agricultural land to feed crops to animals to feed to people. And so that means that those emissions go down. And if you don't chop down the trees, there's some nice system benefits. It's not huge, but actually more trees grow older because they're not being chopped down for ag land for cows again. And so removals, that is older trees pulling more carbon out of the atmosphere through photosynthesis. Put all that together, and what you get is that drop to overall emissions of the pollutants. Temperature comes down, and then, well, what were we looking at? I don't even know if we get to change deaths from extreme heat much, but oh, actually, we do. Those actions brought us from 19.1 in 2080 down to 17.46. So 1.5 deaths per 100,000. We can now connect the dots all the way through to deaths. And Well, that's kind of cool. There is a benefit that you can see. All right, that was the food. And then you said, well, what about some other things? And I'm going to pick up the pace here a little bit. Not, I showed you a lot of detail. You could do the same thing when you test renewables, but I'm just going to boost it. Here we're going to be encouraging renewables even more. They're growing beyond what we ever dreamed was possible. But what if they were subsidized and could grow even faster? Now we're down at 3.0. Another thing that you voted for was energy efficiency, insulation, HVAC systems in buildings and industry, industrial motors that are more efficient. Watch over on the left as the overall use of energy will go down a good bit. Look at the left. We just need a lot less energy. If we invest in energy efficiency, temperature comes down. What if we address the fact that we offer enormous subsidies to the fossil fuel industry, coal, and I'm going to put in subsidies here in oil and in gas. These are all things that bring us down to 2.6 degrees. What else did you vote for? I need to go take a peek. I don't want to make it up. What did you say? What did you say? You said fossil fuels, renewables, food, energy efficiency. Yep, I was right about that. Phase out fossil fuels, deforestation. Phase out fossil fuels. So that is beyond going to just not give them subsidies. But there's actually a lever if you want to push it. Click here, scroll down, reduce new coal infrastructure. Watch the brown area in the top left. It's going to shrink. And what else can be done? We could do the same with oil, reduce new coal infrastructure, and also gas, natural gas. And we'll do the same thing. If we were to phase out these, we get to 2.4. Now, you know what I'm going to do? I'm actually going to pause a second. And you're at 2.4. That's pretty good. And just if you want to, I realize I'm not going to go push it and put in all your things because that's what you're going to do together is to click around yourself. You said you wanted to see deforestation. You wanted to electrify transport. You do that here. You want to see more efficient cars and transportation systems. That's right here. Cutting deforestation. There are 5 types of carbon removal, and you can plant trees. You can go here to direct air capture. You can crush up rocks and see if that helps. You can go over here to fluorinated gases. You can cut leaks in natural gas pipelines. Cutting deforestation, you're at 2.4. But I want to show you how far you've gotten over in the corner. And if you want to share this with each other, copy the scenario link. And I'm going to go over here to chat. I haven't looked at it myself, but here it is. And whoa, go into chat and you can open up this exact link. So in a minute, if you want to just take where I am and see if you can get to the goal. You've heard this goal. The goal, temperature-wise, is to keep this temperature line well below 2 degrees. Here's where we're headed, the 3.3. Here's what you've done with affecting food and agriculture and phasing out subsidies to fossil fuels and phasing out fossil fuels and energy efficiency and addressing methane. All of those actions, energy efficiency, are getting us to get to 2.4 degrees. Your goal is to get to well below 2, and the real goal is down here to 1.5. But really, we don't care about temperature. What we want to look at and why we're here together is a healthier world. Someone talked about Katrina. I'm in Asheville, North Carolina. People died. My neighborhood pharmacist died. Was one of the people exposed to hurricanes and typhoons. much can we avoid what we went through in the future? How many millions of people? So go look at health impacts out here. There are ones we haven't even explored, malaria and dengue. You say, how did you do that? Click on the triangle and you're going to read about it. You can go read about the study. You can go read explanations here. Okay, I've shown some of the basics of how this operates, and I'm setting you up. I haven't shown you the full impact of preventing it, and I haven't helped you with that yet. But I'm setting you up to do what you're going to do in a minute. You're going to get into a group of people, and you're going to ask one of them who is the most tech savvy to open up the model, and we'll send you the link and share it in the breakout room. And you're going to share it with the other two or three or four people, I don't remember the number, who are there. You're going to introduce yourself to each other, and then you're going to say, hey, click on that. Let's go look at this. Let's try this. You can either open up this scenario because you have it in chat and try to get well below 2, or you can start from scratch. But to do that, I think I need to pause a minute and say, are there any questions? And I'll say, Catherine, Ava, Shweta, Savannah, did any of you see a question that's come up? And by the way, you can write your questions in chat if you haven't been doing that already, that would stand in the way. If it wasn't answered, it would stand in the way of these groups doing this well. And these are not going to be super detailed questions like, how did you include deaths from air quality? This is the basics of doing this exercise. So anybody, is the tool already being used as evidence? Actually, that's a question for later. Yes, it is. And maybe Catherine and Ava, you can pull up the link that Crystal made of all the different articles. So yes, it is. So Catherine, Ava, or in chat, is there a question that has come up that needs to be handled before we send people into breakout rooms with their good guidance? And I'm about to show you the guidance in a second, right here.
No, Drew, we responded to all the questions, so we're good to go.
Oh, great. All right. Well, then let me set you up with the instructions. This is what I just said, but for you auditory verbal learners, you're going to go to a breakout room. You're going to land there and meet some people. Go around, name, location, organization, whatever feels appropriate as quickly as possible. Meantime, somebody is going to be pulling up En-ROADS, and look into the chat. You should see a link, both of the basic version, or you could use that one that I put in chat earlier that already got us to 2.4. Share your screen. You've done Zoom before. The person who is tech savvy will know how to do that. All of you look at it together and then say, if it was Mike Hollis and you were open it, hey, Mike Hollis, would you click on deforestation? Because Drew never did open that up. And would you go click on heat and humidity? How much better does it get if we take that action? Go click some sliders. You don't have that much time. You're not gonna create a full scenario. Look around, talk with each other and say, huh, I am surprised by that. I am reflecting on this and it's interesting to me. I heard a voice. Is there a question or an addition?
Yeah, Drew, just a quick question. Are we using the scenario where you left at, or are we using the like 3.3?
You know, as I think about it, because 2 degrees is so beautiful and it takes a lot to get there, I think unless you really want to start from scratch, why not start with how I got you to 2.4? And yeah, I think that's probably best because I'd like you to see what it takes to get well below 2 and then go and look, and you're going to be able to see how much better it is in different places around the world. And let me give you one more tip about seeing that marginal impact. I showed it to you here, right? Here it is for the malaria and dengue. The difference between the dotted line in here. So you're going to get well below 2, and then you're going to look at things, and you can go look. What's cool about it is the map will show you both where were we? We were here in British Columbia, right? And when you look at it, make it big, and here we were, and we can say the difference, it says show baseline. Remember I was showing you this area? And I was like, oh my gosh, this area was blue. It was close to 30 days in this area in 2100. Click on this, and then you see how much better. And see the ones that are like this spot right here where my cursor is, it would have been blue. Now it's green. You've gone from 2 weeks to less than a week. Go look at those areas. That's what you're going to be doing together. So your instructions again, I'll go back to where we were. Any questions about those instructions? Okay. Here's what you're doing. Go meet some people, play with it. I think we're giving you, do we, Shweta and Catherine, do we still have 20 minutes?
Yes, we do still have 20 minutes.
Oh, great.
Yeah.
You have 20 minutes. And then come back and we're going to share some reflections, particularly what was surprising, what was interesting, what was relevant to the world getting on track to dealing with climate and health, preventing all we can prevent, dealing with what's coming. We'll see you in 20 minutes. All right, I see folks returning. Welcome back. Ken and Kareem and Leonard. Leonard, I got to see you and Jamie in that first group. Hope that went well. You were looking at different measures. And Catherine, Navneet, welcome back. Paloma, as you come back, would you go to the poll? And we're going to talk about insights and surprises in a minute. But for now, what did you like or find helpful about experimenting with the model, with the simulator? Go to the poll. And then the other thing to think of is surprises or insights about health and climate, not about the simulator, but that's what we're going to talk about. And we're going to actually hear people's voices for that in a minute. But for now, if you would, go to the poll, just a few reactions. We're always curious about what people get out of this. What did you like or find helpful about it? It was really easy to use once I found the view options. Great. Great. Yeah, it takes a minute to figure it out. Co-benefits and equity considerations, very relevant to the healthcare sector. Addressing waste and leakage didn't seem to have the impacts. Visuals are wonderful. Co-benefits, it didn't have the impacts we expected. Explanations. Oh, you actually got to the explanations. Great. Surprising how effective nature-based solutions can be. Good. It's really easy to use once you found the view options. The depth of possibility to simulate climate policies, co-benefits and equity considerations. Yeah, so as you're coming back, write in the poll and answer what did you find helpful or like about using the simulator. And then we're going to hear some voices. So think about what insights or questions, some people already wrote them here, what insights you came up with. I'll give it another minute to see if there's another one that someone wrote. Last one. Okay, we're going to go here to the share. All right, please raise your hand in Zoom. You have to go under React. There's a little heart. And raise your hand if you have something that you would, as briefly as possible, with haiku-like brevity, to say, I was surprised by this. Some of you already wrote it. I was surprised by how much nature-based solutions helped, or an impact that you saw. What was something that was interesting or surprising? And raise your hand and speak to your colleagues and let us know. Akshatha, please, you have the floor. If someone could unmute Akshatha, and you have the floor.
I think a lot of the interventions that are strongly purported on like news outlets and social media don't quite have the impact that you might expect them to do. You would see that you would say like very high growth, they're very subsidized, and it would have no impact on
Yeah,
temperature change. But these are the ones that the news outlets want you to try and do, like plant a bunch of trees or
interesting.
other things like that that aren't actually as effective as other methods.
Yeah, and just really quickly, where that showed up, you just said it. Uh, some of the things that you hear in the news, the exciting new things that are out there, you mentioned planting trees. Carbon removal is right here. Nature-based, and if we planted a lot of trees of the available land for afforestation, reforestation. Now, mind you, trees are good. We want trees. We need more to plant more trees for many reasons. But are they a significant climate solution? At a large scale, it is fairly small. Why? Because look, it doesn't help reduce emissions until the 2050s or 2060s. It takes a long time for trees to grow big enough to remove a large amount of carbon. And talk about co-benefits and equity. How much land is required? This is over an India of land just in plantation trees to get
Mhm.
that result. So yes, you are right about that. Okay, someone else had their hand up? Anyone who's next with sharing an insight, or you can share it in chat. Yes, Shweta.
Yeah, it was. Our group had really good time playing around with that tool, and then as the last speaker said, it was pretty surprising how some of the policies were more effective than others, and
Yeah.
really a shocker was the nature-based solutions, but also to see that electrification didn't really make much dent, which was kind of very
Yeah.
surprising.
What's up with that? Did you have a theory about why
Actually, energy efficiency had more of a impact than
than
electrification.
electrification?
But I don't
Yeah.
know why, but it was kind of surprising to see that.
Well, definitely people are making more money selling electric vehicles. Um, and here is the contribution it can make. And there's oil, that's what it helps. Here's electric share of total transport. If we electrify a lot and build infrastructure, we could get a lot more electric vehicles and a lot less oil. The challenge is right now, a lot of new electricity around the world is produced with what?
Fossil
Coal
fuels.
and
Natural gas.
gas.
Yeah.
So unless we decarbonize, electrification of transport doesn't help that much. So if you can get renewables and if we can get carbon pricing and get rid of subsidies, which help in their own right, but they also decarbonization and electrification work together. They need each other. And to do one without the other, you'll see very little impact. Yeah. Navneet knew it and wrote it in chat. What source of electrification is great? Um, Cecilia is asking, I have a quick question about the drain of resources with usage and projected large increase in generating power for AI in data centers. It's about 12% right now of data center uses is AI. It's expected to grow. Is that a particular category under the model? Ava, do you have the link to the webinar? If someone was really into it, we did a whole webinar on the four big impacts of AI on climate. Some good, some bad. You mentioned energy. We are this close to getting a grant to go quantify this. So at some point, you're going to be able to test it. But right now, uh, it is part of economic growth and just demands on energy. So look at that. If we have that kind of boost in overall demand for energy, that would put temperature up as much as degrees. That said, we think the biggest impact, and this is not based on studies yet, is the fact that one of its main applications is in increasing yield in finding coal and gas, decreasing cost of coal and gas, and then mapping new areas to discover it because AI is really good at taking photographic images and doing analysis of it. So that's another big consideration. Any other hands? Raise your hand if you have an insight to share or a question. Otherwise, we're going to shift over here to any other questions and topics that are coming up. Cecilia had her question about the tool being used as evidence. And oh, look at that. This is a great link. And this shows some of the academic basis behind it. Here are peer-reviewed journals, articles that it's involved in. So yes, and please go check many of those out. All right. I'm checking to see this. All right. You had the insights you had. Now let's move on to the question of let's go look at that world because I don't want to leave you hanging here at what was that? 2.4 degrees. Let's see what it takes. How did I get here? Did I really go all the way back and undo? I did. Wow. All right. Well, let's put together the scenario without AI. And of course, the most powerful thing we can do on climate change, the most immediate one, of course, is to boost the energy, the clean energy revolution in energy efficiency, electrification, and clean sources like renewables. However, if we don't also put pressure on fossil fuels by cutting subsidies and carbon pricing, we don't get there. The energy system is only part of it. We talked about food and agriculture. We need action there. Cutting deforestation as well reduces emissions and boosts removals. Carbon removal is the kind of thing that could get us to below two.
Drew, you might want to share your screen if
I
you're building a
didn't
scenario.
share. I
Yeah.
wasn't sharing my
Thank
screen.
you.
Boy, I hate when I do that. Well, I'm gonna show, watch this. This is what I meant to show you. Here's a cool thing is you can just do it all again. Watch this. I'm going to hit the back button all the way back to where we started. And what did I say? I said energy efficiency and the clean energy revolution. And I said electrification and emissions come down. And I don't want to look at this. Let's look at something interesting at a couple things on health. Let's go look at some things that we really care about, say deaths from extreme heat. Here's where we started. If we had energy efficiency and the clean energy revolution and renewable energy, better clean sources, pressure on fossil fuels and coal, oil, and gas, air pollution falls. Look how fast it falls and how soon. It's not delayed. It drops in the 2020s, like next Thursday. However, deaths from extreme heat, notice that we've bought this next 15 years. All of you out there in the world thinking about the health implications of climate, most of the temperature-based ones will not get better, even with radical climate action for the next 15 years. There is momentum in this system. It turns like an ocean liner, not like a sports car. PM 2.5 turns like a sports car, but this one turns like an ocean liner, sadly. So we have bought this next 15 years, but more that we can do. 2.2, what did I change there? Cutting waste and leakage of methane and F gases. More in nature-based carbon removal and in technological carbon removal, and we're at 1.8 degrees. In this world, we have less extreme heat. What's one I didn't show you? Less population exposed to river flooding. That's both pollutants, that is riverborne diseases. I didn't show you malaria and dengue. Where is it? Right here. Another impact where we have less of these health conditions. frequency of extreme heat. Instead of in 1850, we had 1 in 50 days had extreme heat. Today, we're experiencing 8. We're headed towards 29, but we can limit that all the way down to 12 in this best case scenario, better case scenario. So I ask you, what would you love about a world on track to making something like this happen? What would you love about a world on track to making something like this happen? Now, I have been talking quite intensively and asking you to do things for this whole time. This has been kind of intense. So I want to ask you to just, with me, we're going to be quiet for 60 seconds. And when you think about taking the actions you see at the bottom, you think about this better world for malaria and dengue and this better world for frequency of extreme heat. And I'm going to time this so we really get it. I'm going to be silent for 60 seconds. Think, what would you love about a world on track to making something like this happen? A minute can feel like a very long time. Okay, would you please go to this poll? And a few of you, if you would, what would you love? Please, a few of you, it's helpful to hear, and then we're going to talk about using the simulator. What would you love about being part of a world on track to making this, something like this scenario happen? Kids growing up in a healthier environment. Thinking about your kids doing it. I'm thinking about your kids too. I would love that. Thank you for sharing that. Somebody else. Well, centered on collective action, opportunity, and innovation versus stuck in old dirty ways. A healthier world for the future generations. Well said. Well said. Yeah. We'll see if there's one more that's coming. If anyone's typing right now. Healthy communities for all. Thinking about what we would love. Clean, breathable world for generations to come. Better equity, a more equitable world, a fairer world. Thank you. All right, the last question. How might you use this thing? Now, mind you, it is just a tool. Like you can go open it up. You've seen it. It's free. It's in 21 languages. It's also embedded in a workshop, something like what you've just experienced, but led by people around the world. And you could, I'm going to show you in a minute how you could learn to lead it yourself, or you can bring in somebody to lead the workshop for yourself and your team. You could join our webinars. We have these. Yeah, so how might you use it? Educate yourself and others. Absolutely. Thank you. Educate yourself and others. How else might you use this? Help visualize and promote policy impacts. Yes. Yes. Help people see what are the impacts of policies. Professional development for public health students. Yeah, and I'm going to show you in a minute what you would give the public health students. Share it with public health advocates to advance climate solutions as health solutions. Perhaps the courses you teach, both geography and public health, educate yourself and others. Thank you. So I'm going to show it about education and also about training. So here in En-ROADS, and could you share the link, Ava, to the training? So this is a free course, and we're actually, your timing is amazing because in 3 weeks is our annual cohort where people go through this experience together, which is our course. It's driven by 63 5-minute videos that you watch to learn facilitation. You learn more what's underneath the hood of the model, what is the assumptions are in the model, how to engage people, how to answer tough questions, how to use the maps. And if you scroll down here, here's the course, and you can see everything that's in it. So go check it out. You apply by just saying, here's how I'll use it in the world. So here it is. Go check out the course. It is available, and you can see what happens in all the different sessions and all of that. Secondly, someone mentioned education. And in the education world, here is our website. We have developed what is really homework. It's the guided assignment. If you go there, it's just this document that if you have students, you could just give them this document and say, hey, everybody, here's your homework. Go click on this link. Here are some good questions to ask. And we have a 10-minute video. We have an hour-long video that you can watch or give your students to watch, or you could introduce it yourself. Other resources are here, of course, will be what's under the hood of the model, what are all of its assumptions, what's behind it, what are the papers that are here, who is using it around the world. And of course, we're excited to engage you and think about how this could kind of build on your work with the Medical Society Consortium on Climate and Health, or the APHA and the work that they and we at Climate Interactive are doing. All right, so I want to just wrap up with a few things that you saw and make sure they really landed with you. Of course, this tool is available. The workshop is available. There's a whole facilitator guide for the workshop, so use the tool. But I want to just land some key things that you saw as you played with the model, and you could test this yourself. And the first is, when you played with it, I hope you noticed that there's no one big thing that we're searching for to prevent climate change. This isn't like a debate or an election of who wins. Like, oh, it's about electrification, or it's about food, or it's about not chopping the trees down, or coal, or renewables, or EVs. Instead, it takes many seeds to plant this garden. It takes many actions at many sectors, at many scales, in order to get the results that we really want. And it is still possible to bend those curves, to create what you'll see when you look at the health impacts are worlds that are very, very, very hard to adapt to and deal with, and ones that are much easier to adapt to. Not easy, but easier. That said, when you look at the health dynamics, we have still on track, no matter what, to have rising warming for this next 15 years of my career and many of yours. So we should be getting ready and preparing the world. And yet if we don't prevent it, we have a world that we really can't adapt to at all. Back to the solution world, there were things that helped a lot and a little. There were things that seem like they're a big deal, like someone mentioned in the public health, in the media world, that don't help quite as much. But there are the ones that are the top priorities. And anything that leads us to not burn coal, oil, and gas in the next 15 years is one of those priorities. Anything that cuts methane, anything that has us protect forests, those are our big five. And to do those first three of coal, oil, and gas, it's the clean energy revolution, and it's some sort of pressure on fossil fuels itself. That said, we can create a much better future. It's not going to be easy. It's going to be worth it. Thank you very much, everybody, and I'll turn it over to my colleagues to wrap up. And oh, I'm looking over here. People are saying these nice things here in chat, but it is time to wrap up. And Shweta does say, please join for the APHA upcoming extreme heat training. Oh, that's cool. I didn't realize we had that. We should pull that up. And the fact that there's a link to that, that there is a training that's coming up at this resource hub on this page. So come to the extreme heat training that's in your chat right there. Any final words for my colleagues? Adele, you are welcome. Ken, I'm glad you found it thought-provoking. Oh, and we have a communications training from the consortium from Savannah. Another one. Maybe I'll give you some share time too. Let me pull that up. And Andrew Garman saying it's very helpful as always. Happy to see it. So here it is. Be a climate communications champion, advocacy skills training for challenging times, starting next week. Okay, fantastic. Cecilia's sharing that you'll be sharing your library colleagues and present it to your manager. Fantastic. You're welcome, Chip. You are welcome. All right. Well, this is 4:30 here on the East Coast. It is time to formally wrap up. And I'm going to stick around and there are other questions for our team, but goodbye, everybody. This is the formal end.
Thank you so much. This was great.
You're welcome.